Okay, after download the file, you can follow the instructions and download the file. Okay, now it's preparing to install the file. So some of you find error that the license is not working. So your installation is okay. The license, I will tell you how to update your license later, okay? So don't worry. So your software is working properly. Okay, then you can go to the next. I accept all terms condition of the license. Next. Okay, you can use any username here. Okay, anything you can write it here. Okay. Next, back. Just a bit. The the folder is very important. Where you install the file in the C drive, so you should know. Okay. Okay. Next, this folder, right? C program file, computer and structure, SAP 2023. Okay. Because already I have this in my laptop, the complete version. So I will just rename it at student version. Okay, so this is the location where we copy our license file. Okay. So you find once the installation is complete, you will find this. Okay. So we need to copy the license file inside the folder. Okay. After installation. So I shared you another file, license file. So we need to copy the license file after installation. Okay. So go next, then install. So this process will start the installation. It may take some time, but you will find another license file from in your in the Blackboard. You can download that file and copy and paste inside the folder where you install the SAP 2000 in C drive. So once you install, you can download the license file, open this file, okay. And this is a file. You need to copy this file. We are copying in this, okay. So now you can just paste this file in this folder. This is the C drive, okay. Program files, computer and structures, incept 2023, okay. Once you copy this file, so you can open now. So this is I already installed this program in my laptop. So
Doctor, please repeat last one.
because in my laptop the program is already installed, okay. So I don't need to install, but you can finish the installation, copy the file inside the folder, okay, where you install this. Okay, this is C drive, right? C drive, then go to the program files, then go to the computer and structures, okay. Then here, this is the folder where you install your software, SAP 2023, okay. Here, copy anywhere, okay. This is a file I download, license file, lsserver.c, this file, okay. You can copy this file and put inside the installation folder, okay. Computer is this in this folder, okay. You can paste it here, Control V, okay. So you can paste it here. This file is already here, so I will not copy it, okay. So after installation, you will find this shortcut on your desktop. Okay, I will share the link for the license also, okay. Okay, still I'm waiting. Some of you send me message that program is still downloading. The deadline for course project is maybe not before final exam. Okay, it's not very recent. Okay, it's maybe after your midterm and before the final exam in the last week of the your semester. So this is not very urgent. Okay, so you can submit the project maybe later, but you can work on the project. Once you finish, you can upload the project on the Blackboard. Okay, you can copy the license file in your C drive, right? I will send you the link. So once you download the program, you install the run the setup file. Okay. Yes, the lecture is recorded, okay? Okay, how many of you finished the installation and setup? All of you? Yes, Omar? Ismail finish, Naif finish, Rakan finish, Muhammad Muqdad finish, Bassam finish. Okay, okay, so some of you finish the installation and okay. So once you finish the installation, then open the window, right? If you open the software, so this is the window, how it will look like. Okay, right? So you can use this window to make your model of your project truss. So step by step procedure I already shared you in the file. In the project file, you find all the steps from the beginning to the end of the project. Okay. So this is your truss. Okay. So this is your step one here. Okay. Maybe this is the older version. Some of the steps are not same, but the procedures are same. Okay. So the first step, you want to make a new model, right? So first step, go this window of the software, file, new model. Okay, then you find this window. How many of you found this window? Okay, Mukdat, it's okay. Naif is okay. Ismail is okay. Wissam is okay. Saleh okay. Rakan okay. Okay. Abdurrahman is also okay. Okay. So this is just step one. Okay. So from here, so we will try to make a follow the steps. I gave you all the steps mentioned in the tutorial. Okay. In the file, PDF file. Okay. I gave you all these steps. So the first thing, you can download this file, okay, then copy the license version inside the installation folder. Then you can open the SAP 2000 program, okay. So the first step, you can use to make a new model, okay. So inside the new model, you find this is window, okay, and then from the pull down menu, you can fix the units first, okay. First, I explain you the tutorial, then I will do the practice on the software, okay. So from here, you can first select the units, so in which we are working. Is your model is given in meter and kilonewton, right? Kilonewton meter. So we will select the kilonewton meter from this pull down menu, okay. Kilonewton meter, okay. Then, so first we need set the units, okay. Second, so this is the first we set the units. Second, we choose the which from the templates. So which structure or which model we want to make it. Okay. So first, if you want to make your own model, you will select the grid only model. Okay. So we need to set the dimensions or the length of the truss and height of the truss. So we choose the grid only model. Okay. Once you choose the grid only model, so it will give you the coordinates. So what will be the coordinates? Like if we are working, this is x-axis and this is y-axis, okay, or z-axis, you can set the coordinates, okay. So if in the tutorial, it is given x-axis and y-axis and z-axis, okay. So this is your y-axis and this is your z-axis, okay. In y-axis, how many grid line we needed? This is one grid, two grid, three grid, and four grid, okay. So there are maybe the four joints, okay. So we need four grid for each joint, each grid for each joint. One, two, three, four. What is the spacing between the grids? 1.26, 1.26, and 1.26. In Y, we need four grids, and the spacing should be 1.26. In Z, how many grids we needed? Two grids, okay, one and two, okay, and the spacing between the grids will be 1.2 meter, okay. So we define that here in x direction we don't use, in y direction we need four grids, in z direction we need two grids, okay. Where we don't, because we don't use x direction, so we just use the default 0 or 1. We cannot put 0, so we use 1. So we will just work in y and z direction, y and z axis. What will be the grid spacing? In y direction it's 1.26, in z direction it will be 1.2 meter, okay. So the third axis we are not using, only we are working in 2D, so the third one we will put 0 0 0, okay. Once you finish this step, so your grid line will show look like this, okay. From here you can draw the members of the truss, okay. So we can draw the members. So we can select from draw, we can select the draw frame, cable, or tendons. So we can draw, select this. Okay. From here, just we connect the joints together. Okay, is mentioned in the figure in the truss. After drawing, we need to assign the supports. We just select the joint and then we assign the supports. Okay, like pin support or roller support, we can assign it. Okay. The next, we can assign the materials. Because this is a steel material, so we can select the material section or material properties. Okay, so this is a steel. From steel we can select these are the default properties of steel. Okay, Poisson's ratio, modulus of elasticity, thermal expansion. We will select just material, then we apply the loads, because loads are applied here. Okay, here joint B, joint D, and joint F, we have the loads, right? 3 kilonewton, 6 kilonewton, and 1 kilonewton. So joint B, D, F, we will apply the loads. So from the load may assign, first we select the loads. First we select the joints, then we go to the assign, then we assign the joint loads. Okay, the forces. So we can assign the joint forces here, and then we can apply some properties like in the Z direction it's -3. We apply the loads for each joints. Okay, because acting in the downward direction, so we put minus here. Okay, and then we can uh, assign some the analysis conditions. Then we run the analysis. Okay, once we run the analysis, save the file and run the analysis, we will find the deflection shape, we find the reactions. These are the forces. Red one is the tension and the yellow one is the compression forces in each member. Okay, and these are the support reactions we found it from the supports. Okay, and this one yellow one is the here show the tension forces, so it will show you the diagram of the tension forces or compression forces in each member. And this is the manual calculation, so you can compare both the results from the software also and from the manual calculation also. Okay, any question? So I think yeah, we can replace the forces, but there is no forces, but always we try to use this command to replace the force. Okay, so this is your software. Okay, so we can first choose the units, right? Well, units are kilonewton meter. Okay, then we can choose the grid only model. Okay, so in X we can use 1, in Y direction 4, and Z is 2, right? What is the spacing between the X direction? We can use this model, right? This one. So between X it's 1.26, between the it's 1. Okay, Y direction, the spacing, grid spacing between the Y direction is 1.26. Then in Z direction the spacing is 1.2. Okay, so you can keep X, Y, Z 0. So we use this. Okay, we got this grid, so we can just use the Y and Z we are using, right? Y and Z, you will find two windows, but you can use Y and Z. Okay, so we maybe this is a two window, but you can work on one window also. The next step, we can draw the frame. Okay, from here we can draw our truss. Okay, So this is like this. This is like this. So we will see the figure how it look like. Okay. So then we have this member. We can minimize, and then we have this member. Then we have this member. Then we have this member. Okay. Once you make escape, it will escape the. So again, we can draw frame or cable. Okay. We can have this vertical member also, and we can have repeat again, uh, draw frame or cable. So we have this member. Okay. Then also we have this diagonal members. Oh, we have this diagonal draw frame or cable. So we have this member also, and then we have this member, and also we have this member. Okay. So we finish to draw the truss, right? Any question you have? Yes, Sam.
Doctor, how to get the recording to revise?
I will share you the recording. Okay, link. So I am
Okay.
recording the session, so it is recorded. Okay, and we will repeat it again. Don't worry, we have enough time. Just today is the introduction. We will repeat it again in the next class. Okay.
Inshallah.
Okay, so we finish to draw the truss. Then we can assign the supports. So joint, restraints. We can assign the supports here. We will see what is given inside the file. Here is a pin support, right? So we can just choose the pin support here for this joint. And for this joint, we need the roller support, right? Assign joint restraints. So we can use this is a roller support. Uh, oh, this is roller support, okay? Only one translation, one force in the vertical. Okay, this is roller support, okay? So what next? We can assign the loads, okay? Before assign the load, we can define the materials. Materials, we are using steel. 4000 is concrete, we are using steel, this material, okay? Modify or show, we can use the steel truss, okay? Unit per unit volume, we can use 0 because we are not designing this section, okay? Modulus of elasticity, you can use the default values, okay? Make it okay, then okay. So this is the steel, then define section properties, frame sections, modify or show, okay? So we are using states, okay, no problem. Anything we can use. Okay, the next is assign the loads, okay? We select this joint, we can assign joint loads, okay? So here Z is -3 kilonewton, okay? So here -3 in the second D joint, we have assigned joint loads, forces, we have -6, okay? Close. Then at this joint F, we have assigned joint loads forces -1, okay? This load you will change, okay, according to your serial number. Once you finish the model, you can change this load, but I am using this tutorial, so I am using the same load, okay? Finish. Then so we assign all the things. We assign the material here, okay? So we apply the loads here, okay? Then this step is just for the analysis purpose. What does it say? Frame, assign, frame. Okay, so we just use this one. Okay. So now we can save this file, save as. Okay, so we can save the folder. Okay, this is your 442 drum, and we have this statics course. Then we have this is 15th editions. So we have this project here. Okay, so we can save this file, trust project, project 442. Okay, save here. Okay, now we can analyze this file. Analyze, run analysis, run now. Okay. Okay, we got this displacements. Okay, so this is showing the deflected shape. Okay, and if we want to see the reactions, okay, so display show the undeformed shapes. Okay, show the forces in the joints. Okay, so we can see the forces in the joints. Okay, we can see it here. So this maybe we can change the deform shape in this window display. Show under deform shape. Okay, then we can say display show forces in the joints. Okay, we can see the forces here, right? So this is showing us the forces. 6 kilonewton is the reaction. Okay, and we have and this is showing the forces in x and y direction. Okay, x is 0 because there is no any vertical or horizontal force, and 4 is the other reactions force. Okay, and we can see here. Okay, this is the reaction forces 6 and 4. Okay, and we can see the display show the stresses. Okay, so this should be the axial force, right? This is the only axial force inside the truss. So these are the compression or tension forces. You select this, you can take the window, it will give you the compression force. Okay, so this is the forces 4.37 at this member. So this member is BD, member BD, this member, right? So this member BD, so we calculate member BD, okay, about this force. Okay, so we can compare our results from from the analysis and from our calculation. So this is all about your project. Okay, so it's very easy. Just you follow the steps given in the tutorial. You will find, inshallah, everything is very easy and understandable. Okay, clear? Okay. Okay, Umar say clear. Okay.
Yes, yes, yes.
So I
We
recorded this
are,
video.
we are
So
Doctor.
yes.
Doctor. So, sorry, Doctor, but we are very, very tired from 8 to until now. We are with the screen, so our eyes is